Okay, I'm just starting this without anything planned. I'm gonna just, wing it. And for the long time, I was thinking about doing this kind of setup where I'll be teaching how to use Python for geospatial science. And since I'm teaching a C203, basically Introduction to Surveying at the Purdue University semester, I thought that maybe I can start with something simple. So I decided to give it a try. I don't know how long this is gonna last. I even don't know how many people is gonna be actually watching it. But we'll see how it goes. I'm just doing it for fun, and I'm gonna start with a very, very simple setup. And the part that I'm teaching right now at this moment is actually leveling. And what is leveling is pretty simple. And actually, I am not ready for anything. So let me just get my iPad real quick so that I can explain what I mean by leveling real quick. And if I can show you what I mean by that. Let me start a new notebook. Let me see. Let me connect it. By the way, I'm also doing this while I'm doing an office hour as well. So somebody may kind of join my office hour. Then I may have to stay away from this live and talk about it later. But let me see. Oops, not this one. I need to create a new notebook. Dotted paper. Give me a second. I'm just creating a Python for Surveyor. Yes. Okay, maybe I can start from here. I'm gonna move myself to the bottom. Basically, what is a leveling is a pretty simple setup. So let's say this is our topography. And we have benchmark whose elevation is known. So I'm gonna say this is 100 foot or feet. Then we have another location where we know the elevation, but this is too far away, so I'm gonna have a two setup over here. This is gonna be our turning point number 1, and this is our location X, where we want to know the elevation of this point, how much is going to be. Let me make sure that there's no one in my office hour. Let me just mute it. Okay, there you go. From this one, we're gonna have a rod setup. We're gonna have another rod setup. We'll have our instrument setup over here. That will have level line red. So let's say this is, let me just make it simple. So 8.00. Say this is 2.00. And we have another setup over here where we're going to have a level setup over there. Another level line. Let's say this is going to be 700, say this is 200, etc. Right? And usually how we do the calculation is we make a field note. We have a station, we have a backside, height of instrument, foresight, and elevation. We started with a benchmark whose elevation is given as 100 feet, and we set up the instrument over there. This is going to be our turning point 1, and we have another point X over there. The backside is 800, which will make this is in a positive, foresight is always in a negative over there, so it is going to be 100 minus 8 is going to be 92.00, and foresight is 2.0, sorry, should be 2.00 over there, so, no, actually, sorry about that. Should be 108.00 because we need to add this in a height to make the elevation of this level line over there. And we have actually foresight of 2.00, which will make the elevation of 20.1 will make as 106.00, and the foresight, the backside of to turning point 1 from the next setup is in a 7, so this is going to be 700, which will make this height of instrument for the second setup will be 113, and backside, the foresight to the station X is 3.00, which will make 110.00. So that's how we calculate, right? So we started from the known elevation. We have 8, which we need to add this height to get the elevation of the height. Then we have a foresight. We need to subtract this one from this height of instrument will give us this 106, and the second is the same. We need to add this height to get this value, subtract this minus 410 will give us 110. So basically what we need to do is we need to do this we need to implement this as using Python. So how I want to do it is actually I want to write a class to do this. I don't know how I'm going to implement this exactly yet, but maybe let me see how can I do that. We'll see. So with this in mind, what I'm going to do is I'm going to switch to my computer screen. So I have my computer screen over here. Oops. And I'm going to go to my Python directory. I'm going to make a directory called the Surveyor. How do I name it? I'm going to call name it as a survey, basically. I think this should work. Surveyor. Okay, survey. Okay. I use Atom as my main editor, so I'm gonna make it, and let me make a class. I'm not going to even make a class. I'm going to put everything into this one. So level, I'm going to make it leveling.py. I'm going to make it as in a Python file over there, save it, And let me see, I'm gonna make it in a class first. So where should I start first? Now I'm gonna make a differential leveling class. Differential level. Ooh, it's been quite a long time. I even forgot how to write a Python class. So, let me just go over here. Python class, or I don't remember classes. Yeah, this is the one that I'm gonna look at it. Let's begin with easiest one is the definition. Let's look at the class name. Okay, so I'm gonna actually doing this one, differential leveling. And usually I do it is gonna define the initializer. Okay, let me see, go back to this one. How do I define initializer? Okay, init and sub. And do nothing here yet. So I'm not gonna do anything. Okay. And what do we need to do first? Define station. Because if you look at this note, let me just go back to note. Because I'm just not gonna mention, oh yeah, I'm just gonna wing it right now. So we need to have each station, which will have basically elevation attribute. So we need to have that. So we need to have a station that is coming in sequence. And those stations need to have a elevation attribute. But it can also have backside and foresight as well. So I need to start with something very, very simple. Okay, and each station can have backside, height of the instrument, and foresight and elevation. And this is easy to attach it to. So what should I do? I don't know. There can be so many different ways of doing it. Let me see. I think the easiest way of doing it is simply make a table like this and write a function to fill in those each of the cells. But I really don't want to do it that way because I think that will make this program very, very difficult to manage. And one of the assumptions here is that this can always have, one of the assumptions that I can make here is that this one always need to have a benchmark as a starting point and another benchmark as an ending point. So maybe let me do it that way. Okay. What I'm trying to do is trying to make a setup like this, and we're going to always start with a benchmark. Okay. So substation, I'm gonna make it DM benchmark name. I'm gonna give a default name as PM. Starting benchmark, DM elevation. I'm gonna benchmark elevation. I'm gonna ask the user to input this in a benchmark elevation as a default. So I'm making self stations. So I'm gonna STANS station. So I'm gonna use an ST to stand for stations. So I'm gonna use a station to make a plural. So I'm gonna make it as the empty list for now. Then I'm gonna self append this to have a benchmark name to have the first elevation. Self station elevation. So let's make it another list or array, but this is going to be specifically in a numbers. So let's make it as an BM elevation as a number. But do I want to make it as a numpy array? I think maybe. So let's do it. I'm gonna make it import numpy as numpy. So I'm gonna make it as a numpy array. And let me see. Actually, can we numpy append? Oh, numpy does support the append operation as well. Okay. NP array. I'm gonna make it default array to be this one, and D type should be NP float 32. I mean, that 32 should be good enough. So let me just make it initializer only, and let me go to my window here. Python. Let me make a new virtual environment because we are going to be dealing with this a lot. So conda create minus new, name should be survey. So I'm going to make it in SB to stand for survey. And let me see. Now don't kind of whisk it. Let me just go back and make sure I'm doing this correctly. So the usual way how I do this, go to Google, Conda environment tutorial. That's usually how what I look it up, managing environment. So if I want to create a new environment, command here. So okay, yeah. Conda create minus any survey, and the Python. Let me see. What is the latest version of Python right now? Python latest. Okay, 3.8 is latest. Okay. 3.8, do you want to go with that? I don't know. Let me just do it. 3.8. Let me see if it works. Okay, I'm creating a new virtual environment. Everything looks pretty good. I can see the Python 3.8.2 is being installed. So I'm gonna click yes. So I'm creating a new virtual environment. And for this one, I'm gonna just do this. And conda activate survey module. You can see now in survey virtual environment over there. And let me see if IPython works. You know what? Actually, this one is running 3.7. So it seems like they're running IPython in the base module, which I don't want. Oops. For some reason my Bluetooth keyboard connection was lost. But I'm still in survey virtual environment, so I need to install IPython. Let me run it. See if it works. Yeah, now this is 3.8.2, which is the version that I want. But I don't think NumPy is not installed yet because I just created a virtual environment. So conda install NumPy. I need to install that. I'm not gonna need this iPad for a while. I'm gonna just put there. Just run this IPython again. Import NumPy as numpy. I think it should work. Good, good. So I'm gonna set import leveling. Ooh. Not default argument follows default argument. What am I doing wrong? This one here, managing environment. I don't need that. I don't need that. I can close that out. I can close that out. Classes. I don't see anything wrong here. Let me see. Let me go back to my item here. I'm not gonna do anything. Let's just make it as there's nothing that I'm doing here. I'm gonna make this as just comment this out, save it. Let me. Okay. I'm gonna make it a new variable leveling and differential leveling, and STS is empty. So I think this one is good. Okay, BN name to be benchmark starting, or I'm going to just name it as a PM0. BMS. Yeah. Let me see if this one works. And let me see if this reload thing is working. Okay, this reload thing is the kind of thing that I worked a lot when I used it a lot when I was using Python 2. But for some reason it is a thing. So Python 3.8 IPython reloading module. So I need to look it up. Auto reload. Scroll down. You can use Python reload function. This function is built in Python 2 starting 3.4 is imported from standard module import line. In many cases, this surface after editing a module is described briefly using Stack Overflow and elsewhere online in more detail. Okay. Powerful feature of Jupyter Python is that you can interact with the data from Python command line in order to provide this functionality. The module which hold the data remain alive between invocations, etc. Can have puzzling consequences, especially to programmers who are more used to compiled languages with maker style, dependency change detection, etc. Blah blah blah. So it seems like it is an amaze, basically. Yeah. Reload module in Python 3. Reload module was this one. Okay, so that's what I need to do. Import live, import live, reload. You know what I'm gonna do is from import live, import reload. Okay, now this has been reloaded. So I'm gonna just close that out. So TT is leveling, differential leveling. Just give nothing there. Stations. Okay, PMS came in. So I don't know why this one didn't work. Oh, that PM elevation. So I need to give some default value. So reload leveling. Oh, okay. What should I do? Well, I'm not going to make it as a requirement. What I'm going to do is just make a default placeholder for each variable. So I'm going to also make it as an elevations. So that let's get initialize with an initializer. All right. So I'm gonna just reload leveling. TT is equal to leveling differential leveling. I think I need to give need to make a class, right? That's what I made. Okay. Next, add. I think the Python way of the defining function is okay. Python function name convention. Okay, type of Python code. Let me see. Function. I think I saw it somewhere. Naming convention here. A bit of mess, and I get complete consistent nevertheless. descriptive naming style, single or lowercase. Okay, let me just read it. There are lots of different naming styles. It helps to be able to recognize what naming style is being used independently from what they are used for. The following naming styles are commonly distinguished. Single lowercase letter, single uppercase letter, lowercase with underscore, uppercase with underscore, capitalized word, or cap words, camel case, or name because of bumpy look of the letters. These are sometimes known as totally caps. These acronyms in a cap word capitalize all the letters of the acronym. Thus, HTTP server error is better than this one. Mixed case differs from capital letters. Okay. Names to avoid, etc. Class name. Okay, class name should normally use the cap word convention. Okay, that's what I did, right? Go back to my note here. I was using cap word convention, differential leveling over here. Is this good? Type variable names. Names of type variables introduced should normally use cap word preferring short names. T, any star, none is recommended. Exception, global, function and variable names. Function name should be lowercase with words separated by underscore as necessary to improve readability. Variable names follow the same convention as a function name. Mixed cases are allowed in okay. So it is recommending to use function and variable names should be lowercases with the words separated by underscore as necessary to improve readability. So I'm gonna add station name elevation. So whenever we want to add the self station append name, self elevation append elevation. So basically we are adding that specific station at the end of the array. So oops, this is the reason why I need to keep checking. Or you know what? I think probably I need to record this screen separate because I spent quite a time just showing nothing over there. That hurt. But that's okay. Long story short, I made a lot of mistakes, but this is the part that I kind of reached. I just made an initializer of the class so that I'm going to initialize the station as a list, elevations as a numpy array, and initially try to add default options for this initializer as a class the function to do something, but decided not to because I did not there's some errors. You see this one at the top over here. There's nothing. I just make it as a kind of doing nothing other than initializing arrays and adding another function here, add station, and basically name of the station, elevation of the station, etc. And you know what? Actually, those station can also come with a value that is unknown, right? And when it is not given, it should get come as not a number. So let me check what is in a Python non-value convention. NumPy none. So numpy none. Oh, np none can be an option as well, right? So if the elevation is not given, and I'm gonna give as a np none as a default value. Okay. Okay, reload leveling. So basically that's what I was doing. Just go back for those of you who kind of missed it. This is the one that I did, because in Python 2 this reload was kind of built in, so you don't need to do anything. But I think from Python 3 they changed it to as a, something you have to import it manually. So this is what I did, basically to load this in a leveling module, and just using a Control R to just search backward. And this is basically anything that I just typed in before, I can quickly search it. TT and stations is empty. TT elevation is empty. There's nothing over there. So TT add station, I'm gonna set a benchmark starting is 100.0. Ooh, you know what? I forgot to add the self in the first, because inside this class I need to have this self always as a first argument to the function to specify that like to class itself. Okay, let's reload leveling again. TT add station. Name of the first one is benchmark starting. Okay, so let me just test it. So basically this saying that the NumPy doesn't have a the function called the append. So np append. So basically TT elevation is the empty array, but I think that this append is a function that I have to give. So TT elevation and 100. Yeah, so this is how it should work. So instead of this one, np append TT elevations. You're gonna add that elevation value to the current NumPy array. So I'm just changing it. Load leveling. Add benchmark 100. Ooh. Not TT. This one should be self. Self, right? So I'm gonna reload it. I'm gonna create a new instance of this differential leveling and add. So now TT stations. We have this one, TT elevations. Oh, you know what? I need to assign it back to elevations. So basically, it is not doing. It is, pending it, but it's not saving to that one, specifically. So I need to do this again, reload it, initialize it, add it. So stations, we have this one, elevations. Oh, we have that, yeah, correct one. So what if we add TT, add station, turning point 1, and nothing. Stations, now we have a benchmark starting point and TP1, TT elevations. We got the non-value, which is good. So this is exactly what I wanted. So we are good. So we started with the benchmark. So going back to this program here. So we created a mechanism to actually adding this station manually. And starting elevation here, always we have backside. Now from that one we can calculate this height of the instrument. So we can add a station, which is something that needs to be done automatically. And we are gonna, after we are adding a station, we can add a setup, right? And always in the first setup is going to be looking back and looking forward, those two setups. So we start with the benchmark. We start in our first setup. Then we can add a backside. Next one. Okay. So basically, this is what I'm doing right now, trying to think, what's going to be a kind of logical way of doing it. We have a first benchmark that was done by adding a first station manually. You add the next point. So after you're adding another station, we can set up an instrument somewhere in the middle so that we can set up the observe backside and foresight from this first setup. So what I need to do is I need to add a function called add setup. So going back here, so I have a way of adding station, but I also need to have an add setup. So I'm gonna call it this way, self, and the backside and foresight. Oh, you know what? Actually, I'm not going to worry about documentation at this moment. So basically, when we are doing it is we need to make sure that this setup has how should I say? Do I need to make a setup for? Do I need to give a name for this? No, I don't need to, because I can programmatically to do it, right? So all I need to do is every time I'm adding a setup, is going to be adding backside and foresight automatically. So I need to initialize again self and the backside. Same thing again, empty array, empty, and the type is going to be np numpy for 32. I think that should be good enough. Self foresight, np array, the type np for 32 as well. So backside, foresight. So I'm going to add the s's over here to indicate that this is actually, plural. So adding foresight is self, backside is going to be np append self backside, and the backside over there, self foresight is going to be np append self foresight and foresight. So whenever we add a station, we first start with the benchmark, and we are gonna set up the next station. Then we can add the backside and foresight. Looks good. So let me just going back to an example here. What I want to try to do is, let me just turn on this node here. First, I'm gonna add this benchmark, and add the second station with a turning point 1, and from that one, I'm gonna actually observing backside and foresight by adding a setup, and that'll calculate the height of the instrument. So as a setup will automatically calculate all these values. So it should be done automatically, right? So as setup should done value calculation automatically as well. So let me make sure that actually, I'm not going to even worry about checking the result at this moment, because I'm assuming that users are smart enough to know all the structure of the data set. So I'm not going to worry about it. I'm going to just try to implement this in the whole idea first. So edge setup is like this. Then once you do that, and you should be able to calculate the height of the instrument. So self height of instruments should be np array empty. D type should be float 32 as well. Now calculate hi from backside. Okay. Let me see. I need to know what is my current setup right now. So this case, first one is going to be my first setup. So how do I know my current setup? Because simple looking at the size of this BS backside NumPy array. So index, I'm going to call it as index, or I'm going to just call it I, is self BSS shape, and first one basically looking at that will give us the size of the array. So this is my current setup that you are adding, and from this one what you need to do is, let me just look at the note. Look at the note over here, and self height of instrument. Oh, you know what? Actually, you need to self height of instrument should be np append. There's nothing there. Height of instrument, and you need to add a new item to this one. So it should be self elevations of I-1, which should be the elevation of previous station, and plus backside. Yep. Sweet. Then self elevations of I should be self height of instrument of current one minus foresight. Yep, I think this is it. So we'll load leveling. I'm gonna do this tt add station bm 0 100 tt add station tp1. We don't know that one yet, and the tt add setup, and the backside is 8, foresight is 2. Okay. Elevation tt. Okay, it is telling me that tt elevation and shape Basically, it is telling me that the elevation of I instrument is calculated correctly. Oh, I think by the time it is updated, I think it is not seeing this updated height of instrument array yet. Probably that's the reason why it is giving me an error. So what I'll do is basically self elevations I-1 plus backside. This is actually in height of instrument of current set one. So I think I'm gonna just manually do it. So let me just do this again. Load it. Initialize at the first benchmark. Second benchmark. Oops. I didn't. Adding the setup here. Okay, TT stations, TT elevations, 100 and 106, TT backside, TT foresight, TT height of instrument. Okay, so basically that one should be I think it is working pretty good. So I implemented that one. Then I can add another station with X, TT elevations, TT stations, axis over there, TT height of instrument. It's not calculated yet, but the TT add setup. And basically backside is 7, foresight is 3, TT elevations has been calculated to be under 10. Yeah. So TT backside is that one, TT foresight is 2 and 3, matches with it. TT height of instrument is 108 and 113, and the TT elevation is that one. So if you switch back to this one over there, and you're seeing exactly the same table, right? Elevation 100 is there, 106, 110. Those are the 3 elevation, and a backside 2 and 8 and 7. So 8 and 7 is here. Height of instrument 108, 113. Foresight is 2 and 3. So we implemented exactly the same table that we saw in this class. Okay, so if I want to test this out, okay, how can I do that? Now I think there is a trick that I want to remember. Python change into extend. I'm not sure if I'm no, this is not the one that I'm looking at. What I want to do is that inside this one, I don't want to kind of import this one, but I want to make this one as a standalone program. Utilize this one at the top. So what I want to do is I think this might be something that I can.
One of the great challenges in this field is knowing enough about a subject to think you're right.
Hey guys, in this we start
I don't need.
Before and what
Let me see.
in the description. Choose here is test button. So just click on
No,
test.
not this one. Not this one. You know, I even don't know how to explain this. Okay, Python use as module and stem executor same time. Either I can import that as a module or I can run as a standalone program as well. What is it? What is it? I can't remember. I can't remember what it was. How can I forget that? Oh, you know what? Let me just try to see if I can find it from the older library. Let me just. I might have. I might have something in the all the way back that I did created a long time ago. Which one is gonna work? Oh yeah, this one. If the name is equal to this, yeah, that's exactly what I was looking at. So if then import I don't need to even import it because I let this, do this one. So if I just run as a standalone executable, they're going to run this in the program. So this is how I'm going to make a differential leveling. So I'm going to initialize it first. And DL add station first benchmark starting is going to be 100 DL add station and turning point 1 and need setting up a new observation, so DL add setup, and the backside to this benchmark. How much was it? Let me just go back to my note. Was 8, and the foresight was 2.00. DL, then add another station, DL, add station X, DL, add setup as 7 and 3. Okay. Let me just go to Python survey. I need to activate survey module first. Now I'm gonna run this program, Python leveling. Sorry, it is not doing anything. Well, let me see, run. Yeah, DL stations. Okay, next thing that I want to do is that I want to print in a write a function to print out this definition print self basically. I want to make, basically print this out. This can be, very tedious because there can be so many different options. Let me see, try to emulate this as much as possible. So I'm gonna first print the header, station, backside, height of instrument, foresight, elevation. Basically, I want to just print that, and DL print. So I want to just run. How can I have an error? Ooh. Did I misdo some foresight? The foresight need to be minused. For some reason I think I deleted it. Okay. Okay. It is printing okay. But maybe let me just make it 30. So I can get, let me make it 40 character. So I'm gonna have enough. And basically, if I look at the DLSTS, we have a 3 station. So each in between station, we are going to always have setup. So in this case, we're going to need to print out total of 5 additional lines, right? Okay. Okay, so for I, so we need to determine how many lines that we need. For I in when DL, yes, yeah. So range, length of self STS. We're gonna print first out the name of the station. So print. Okay, it's a good time to Python Can do it this way. Okay. Now this is the old way of doing it. I want to use this print. Okay. Okay. So I want to print PS, height of instrument, foresight, elevation. That's basically, how do I format that though? Oh. Okay. The string should be empty for nothing, so for that format and the first one should be, let's start with one by one. Format should be self station I. The next line we need to print height of instrument I. I'm gonna save it. Run the program. What am I missing? DL. Oh, okay. -1. No. Print. I just want to check how this one looks like. Okay. Last one we don't need to, right? So what I need to do is, if I is equal to when self station -1 continue false. I'm gonna run it again. Okay, so basically what this one is doing is it is preventing to print out last station. After that one, we don't need to print out actual height of the instrument. Okay, I think we are good here. So basically we need to do some formatting over here and need to add backside if there is any. And first one here is going to be actually self backside I. Okay. We're not going to have a backside if we have. I'm going to have another if statement here equal to 1. Else I'm going to print the full thing. If there is a last one, I'm not going to print out the backside. Basically, that's what I'm doing. I need to save it. Make sure I'm saving it again. Yeah. I don't need a backside. Okay. Okay, I think it is forming a shape. And the foresight, I need to print out the foresight as well. First line, I don't print out the foresight, but from the next one, let me just make it simple. If I is equal to 0, solve else if when last line we're going to be only printing out printing out. Let me see. This is what I'm looking right now. So first line, I'm only printing out the elevation of station and the backside. Last line, I'm only printing out the elevation and the foresight. So when this is the last line, we need to have something more. I'm not gonna, worry about this. Oh, backside and elevation. So we need to have something in between here. And name self backside I. This is something that needs to be added. And we need to have self backside. And with everything else, we're going to print full, right? In case of station. If it is not a station, not as so in case of station, we will have four numbers. So name, backside, foresight, and elevation. So name, backside, let me see, for the first line. This is 0. Next is 1. Backside always matches. Foresight is always one behind. Foresight is always now this is should be in a foresight. Should be equal to 1 over there. Name of the station, self backside I minus 1, self foresight I, and the elevation. Let me see if this works. I need to let me just group them with a different parentheses. Oh, well, I think is this? Okay. Index is out of bound, so basically the last one name of the station. Should be this way? Back benchmark 800, TP1 7. Okay, TP1 should be backside. I think it should be this way. Let me just format it a little bit. Okay, now is formatting time. make it look like a little bit more readable. See, what I'm doing. Oh, I always forget to go back. So first line should be basically what I'm trying to do is try to match this one with the, I'm just want to make sure that, this left side is matching with this one. So I need to probably go 3 more. Okay, this one match, but height of instrument is not calculated. Just adding a bunch of spaces. I need to add one more. Yeah, I think this one matches. Next one is in a back side. So should be, I think this one should match. Oh, you know what? I need to make it fixed. I need to make it fixed width so that how many characters? How can I fix the number of characters in Python? Go back to this one. How can I do that? Length. We can do that as well. Can I tennis? Okay. Okay. Up to 10 character is this. So I need to do 10. 10. 10. So probably I don't need to do this. I can just use this space. As a character. Let me see if this works. Okay, 10 characters up to over there. So let me make it 12 character. Okay, so now I can have up to 12 character. You know what? "12 character plus space." And let me just do it that way. And the back side can have. I'm going to use a feet as an example, so make it. How can I format? Floating point numbers. That's the character. Okay, xylophone. .5 padding. Oh, I can force it to have up to 12 only. So I guess this is not going to make any difference, but you do. Ooh, okay. But if it is shorter, it makes it even shorter. But if I do 10.5, oh, I can specify what is the maximum that I want to go. It's a 12, right? So yeah, I think that this works. If this one goes anything over 12, they're gonna truncate automatically. So I think this is good. Let me look at the numbers. Percentage D, percentage F, 40. Oh, I just give them format over there and F. So what I need to do is actually, how many digits we'll need? 10.2F. Let me see. Wanna truncate to the left. How can I truncate to the left? You know what? I can probably make it. Try to match it over here. So I don't need this many, does it? I don't think it's gonna be this long. So it can be native. No, I don't think so. Six or seven. So we're gonna have 4 numbers. Or 8. Yeah, let's make it 8. But I appreciate probably. Yeah, I think that these 2 are now matching, which is good. And TP1 should be now 8.2F. Let me see if this one works. Oh, I don't even need to worry about it. 8.2. There. 8.2F. Okay. Now this one looks good. And foresight, okay. And for intermediate that we need to print. So this is right after the first line. I'm gonna print out. I want to print out the name. Let me just check that. Note. That's just an height of the instrument. That's it. I even don't need to print out anything. Height of the instrument. So height of instrument I, bud, I don't know why this one is suddenly giving me an error. Oh, I forgot to close the parentheses. Huh. Why am I getting this kind of weird things happening? Okay. That one is good. Of the instrument. Okay. Need to do this. Okay, I think this one is good. Now I need to align this foresight. Okay. Let me just take a break. I'm gonna go to the restroom and come back real quick. Okay. Okay, we're almost done in terms of printing. So what we need to do is we need to match this in a foresight. So foresight one that we have is this is the first line that has nothing to do with the foresight, and feel like this need to have a similar kind of width. So I'm just matching this one to be approximately the same. So between the VS2 height, let me just make it at the same distance. Okay, and this is in a foresight value. This is the last line. This should be the foresight value. Okay, but there should be a lot more space in between. Actually, just one more. And elevation should work a little bit further away. One more. I think elevation is matching. This one is matching. Okay, need to do the same thing. 8.2F. I think a 3 dilation is going to work. And 8.2F. I think that is matching. The last one should be cancel the last line. Okay. 여보세요? Okay. Sorry about the interruption. Actually, I got a phone call that I had to answer, but I'm back. But basically, I was doing nothing in between when I was in a quiet period. But basically, all I need to do online is this last one. So the last line represent this one over here. So I need to basically add a bunch of space. Ooh, in one shot, I made it right. So I need to make this one longer in line, so I need to multiply by this 55, maybe more, 65, let's see. 65 is too much. Let's make it 63. Yeah, let's make it 61. I think this is good. So let me see. Do I want, of course I want to add this in a line at the end for sure. Add this line so that I have a line starting at the bottom. Let's add these lines to see how it looks. I think it's not a bad idea. So let's try to add these lines. And I think this one looks better without the line. Yeah. This one looks good. And let me just go back to the initial field note that we had to see if it matches with that. So going back here, 800, 108 high instrument, turning point 173, 106, 113x. Oh, actually, these three should be backside. So for the last one, I should be pasting this one over here. Yep. Yep. Now, what is wrong? Eight and 2, it should be 2. Yeah, I think this one should be -1, right? Yep, that's it. Now what I was looking at was this one was not matching with the backside that we had on the note. So basically what I did is I need to change this one into I-1. Because the foresight is always 1 in the back. This makes sense. So what I want to do is that I want to check quickly to see if this one. Let me just make another setup. The one that I want to check is this one here. Going back to this leveling note. What is a leveling note here? I don't want to check is this example. So DL2 is a differ. So basically this is the one that I want to check. Differential leveling, DL2, add station, and basically PM mil is my station, and the height is at 2053.18. DL2 add station TP1, DL2 add setup, and backside is in 1.23, forward side is in 8.37, and DL2 add station TP2, DL2 add setup, backside is 0.22, forward side is 7.91, DL2 add station TP3, DL2 add setup, backside 0.96, forward side is at 11.72, DL2 add station TP, not TP4, PM bulk, DL2 add setup is 0.46, 8.71, DL2 print. Testing another example. So this is the one that I got, and let me check with the result that I got. 1.33, 18, 51, 0.22, 8.37, 45, 69, 29, 44. Ooh, looks good. Actually, let me check with the rest of the setup. I think that this one is actually working pretty good. So I'm gonna add this, going back to the table. So DL2 add station TP4, DL2 add setup is a setup of 11.95. DL2 add station and TP5, DL2 add setup of 12.55, 1.68, DL2 add station EM mail. Yeah, we are coming back to the point. But yeah, I will have to update this function to indicate that this last station that we're editing is the starting point, but I'm not going to worry about it for now. So I'm gonna run the program. Yep. 65. Yeah, it matches exactly. So you wrote the program. Good. Print. Just I'm gonna add another line at the beginning. Looks good, good. So today we actually implemented this differential leveling using Python. This code. There is a lot of manual, tedious part that we need to do to print out the table, but I think it turns out to be okay. So I'm happy with it. So I'm gonna stop streaming now, and we'll keep working on this as we have more later in the week. See you later. Or probably I have to say that, let me just close it with some kind of comment. So this is the first time that I'm doing live streaming of this Python programming for surveyors, and I know there's a lot of mistake that has happened, because sometimes I forgot to switch the screen. I was looking at my screen over here, but even though you're looking at the computer screen, or I was working on this computer screen, but I left my the streaming screen to be pointing to the iPad. So there's a lot of mistake over there, and plus there's nobody watching this recorded. The live stream at this moment, but I'm just want to keep doing it. So anybody who is interested in using Python for any types of surveying related work, I hope that this survey is good resources so that we can share programming skills with others. So I'm going to stop here for today's streaming, but I want to keep working on this so that now, the problem that, hanging problem that we haven't addressed yet is that how we're going to actually handle a case where the last point that we're going to close the leveling is going to be, starting point. So when you have, the closed loop, the current implementation doesn't know how to handle that. So, how we can actually, make it possible, I don't know, how we can do it, but we will see how it goes. Or eventually, I think, we don't need to make a difference between, closed loop versus another open, but, you're ending up, you're leveling at another benchmark where you're having a known elevation. So I don't think we need to actually do that. Only thing that we're going to make a difference that the final elevation should be some known value. From that one, maybe we can calculate the closer. So I think we are going to working on that in the next stream. So because I didn't expect I'm going to be doing this for 2 hours, but I think it was kind of fun to do it, and also kind of refresh some of my memories how I did that. So I think I'm planning to keep doing on this. So until I see you next time, take care.